This short guide to object orientation is taken from my complete C# course, which you can join for free. Now, that course contains over 4 hours of video instruction, and you can just sign up by going to bitwisecourses.com, and the course also includes sample projects, all the source code, plus an ebook. Okay, so that's over with. On with this short video. C# is an object-oriented programming language, or OOP for short. Many modern languages such as C++, Objective-C, Java, Ruby and Python are also object-oriented. You can think of an object as a sort of a package that wraps up data, and that's variables such as string and numbers, and behavior, and that's functions or methods that do something, often by manipulating an object's internal data. The definition of an object is called its class. You can think of a class as a blueprint for an object. It's just like the blueprint of a car. The blueprint defines all the fundamental features of a car, but you can't actually drive the blueprint. To use a car, you have to create one based on the blueprint's definition, and that's what you do in programming too. You write a class and you create usable objects from it. In fact, just as you can create many cars based on a single blueprint, so you can create many objects based on a single class. One of the sample projects in this course is a simple adventure game, and we'll start work on coding it soon. Now let's think how a game could be represented in terms of classes and objects. I've decided that everything in my game, that's all the treasures, rooms and other objects, will have a name and a description. So I start out by defining a basic thing class, with variables and methods required to handle the name and the description. And I can create from this thing class any number of individual thing objects, each of which has its own name and description. So now I decide I need a separate treasure class, and also a room class, and these will be the blueprints from which individual treasure and room objects can be created. These two have names and descriptions, but since I already have a class that handles those, I decide that I make both the treasure and the room class as descendants of the thing class. Now this is one of the key features of object orientation. You can create a simple class and then define other classes, more complicated classes, that inherit all the features of the simple class and add on new features of their own. So that means I don't have to recode the same features over and over again. Now the treasure inherits everything that's already defined in the thing class. Here that's its name and its description. All I have to do now is add on any extra data or behavior that's specific to treasures. So here I give the treasure a value. Now even though I've only coded one specific new feature, that's value, in the treasure class, it actually has name, value and description. It's just inherited name and description from its ancestor class, thing. And the same is true of the room class. It also descends from thing, so it automatically gets a name and a description, and it adds on one extra feature. And in this case, that's the exits of the room. Now when I talk about features in real code, these might be a combination of data, variables, and behavior, that's methods. And we look at actual code in later videos. And I can carry on creating further levels of subclasses. Here, weapon descends from treasure. It inherits the name, description, and value, and it adds on destructive power. Meanwhile, the jewel class descends from treasure too. So it has a name, description, and value as well, and it adds on one more feature, type of gem. So now this is the situation. I have a jewel and a weapon, which are special types of treasure. I could say that the jewel, the weapon, and the treasure classes are also special types of thing, because the thing class is their ultimate ancestor. And I can go on to create other lines of descent. For example, here the vault class descends from room, so it inherits name, description and exits, and it adds on combination lock. The vault class does not descend from treasure, however, so it doesn't have value, nor does it have any of the special features of the descendants of treasure, such as destructive power or type of gem. And now, with all these classes to choose from, my program can create objects based on all these different types of class blueprints. Thing objects, treasure objects, weapons, jewels, rooms and vaults.